So if we look at example 15.2, the only difference really with this problem is that now we're looking at an applied force that is variable. Okay, there's nothing really too fancy about this. The previous problem we did, we looked at a constant force that was being applied, which means that it was a constant impulse, but now we have a variable force, and this variable force is P equals 100T. So we've got a crate here, it's 25 kilograms, and it has this variable force of 100T. Determine the crate's velocity 2 seconds after P has been applied. It has an initial velocity now of 1 meter per second down the plane and a coefficient of kinetic friction, okay, equal to 0.3. So we need to find velocity. Again, we've got force information, we want velocity, we have velocity, we want velocity, and we've got time. So we can use the principle of impulse and momentum. Now, because it's going down an incline, we can choose our x there, it's positive in that direction, and our y, positive in that direction. And important again, as always, draw a free body diagram. So we've got the weight down, we've got the normal force, we've got friction, and we've got this applied force which is varying. It's a variable force, non-constant. So we've got 4 potential impulses acting on the crate. But again, if we break it up into its x and y, what's happening in the x direction? Remember, down is positive. So we've got, it starts off with mvx1. Notice that the 1 here is positive. That's very important. It is positive. We chose down as positive. It's moving in the positive direction, so we have to say +1. Okay, it's a vector equation. Now we need to consider all the forces that apply impulses in the x direction. Does this force apply an impulse in the x direction? Yes, it does. It is a variable force, so it stays inside the integral 100t dt between 0 and 2 seconds. What about the normal force? No, because it's perpendicular. What about the friction force? Yes, the force is 0.3 times the normal. And it's in the opposite direction, so it's minus 0.3 times the normal times the time. What about weight? Yes, it's got a horizontal component. 25 times 9.81 times sine of 30. There's the force there, and there's my time, times 2 seconds, is mv2. Okay? So now we end up with this equation, and we've got 2 unknowns. So now what we can do is, instead of applying the impulse and momentum in the vertical direction, which you can do, by the way, nothing wrong with that, we'll just simplify it and apply the equation of equilibrium in the vertical direction. We calculate the normal and we calculate our velocity. Now, again, you can use force and acceleration, right? In the x direction, sum of the forces equals mass times acceleration. All the forces acting here, and you'll end up with an acceleration that is a variable, is changing with respect to time. And then we can just carry out our kinematics. This is all chapter 13 work, and we can calculate our velocity. But notice over here we had 2 steps to get there. Okay, here we could write it out in 1 step. Alright, okay, I hope you guys are getting it.